Hi folks, we're going to take a look at the question number 2 from the motion in a straight line homework from February 23rd. In that question they give us the position function for an object moving in a straight line, and they want to know when the object is speeding up and slowing down. Okay, so we saw that in order to determine when an object is speeding up and slowing down, we need to look both at the velocity and the acceleration. That when the velocity and acceleration are in this have the same sign, the object is speeding up, and when they have opposite signs, it's going to be slowing down. Okay, so the first thing we should do is calculate those velocities and accelerations. So the velocity is just the first derivative of the position function. So here we've got 6t squared minus 27 times 2, 54t plus 108. Okay. And then the acceleration function is just the second derivative of the position function, so the derivative of the velocity function. So here we're left with 12t minus 54. Okay. Now since the only thing we have to determine is the sign of each of these functions, the way to do that is to first determine when they're equal to 0. Since these are polynomials, the only places where a polynomial can change sign is at an x-intercept. Okay, so first thing we'll look for where the velocity is equal to 0. So here I've got to solve this thing equal to 0, and I see right away that there's a common factor. Looks like a common factor of 6, so let's start by factoring that out. So we're left with t squared minus, that'll be 9t, and then 108, so 10 divided by 6 goes in once. I'm left with 48, so that'll be plus 18. Okay, equal to 0. And luckily this looks like this factors. So we've got t minus 6 and t minus 3. Okay, now if it didn't, it's quadratic, no problem, you just use the quadratic formula. Okay, so the zeros occur at t equals 3 and t equals 6. Okay. Let's do the same thing now with the acceleration function, since we need to know the sign of the acceleration function. So a at t equal to 0. So we've got 12t minus 54 equals 0. So t is equal to 54 over 12. So that's both divisible by 6, so 9 over 2. Or I'll use 4.5 in my diagram. Okay, and this brings us to how I'm going to bring this all together to determine when they have the same and opposite signs. And what I'm going to do is I'm going to set up two number lines, one on top of the other, one for velocity, okay, and one for acceleration. And I'm going to do similar to what we did when we had the three graphs for position, velocity, and acceleration, had them lined up so that it was easy to compare them. Here, though, since I'm only interested in the sign, I'm just going to make two number lines to display the signs of these functions. Okay, I'm only interested in what's going on after t equals 0. Okay, so I've got the velocity, which is 0 at 3 and at 6, and then I've got the acceleration, which is 0 at 4.5. Okay, now these are the areas where the sign might be different. And similar here, I've got just these two intervals that may have different signs. So what I'm going to do is I'm going to draw these dotted lines so that I can look at all possible scenarios where I have to consider the sign of each. Okay, so let's start with this interval for velocity. So for 3, let me pick t equals 1. So here 6 doesn't change, so 1 minus 6 is negative, 1 minus 3 is negative, so in this interval, the velocity is always positive. Okay, let's check the interval between 3 and 6. Let's say I take t equals 4, so 4 minus 6 is negative, but 4 minus 3 is positive. So I know that in these two sections, okay, the velocity is going to be negative. Now let me go here, take something bigger than 6, so take 7, so positive and positive. So in that interval, the velocity is positive. Now I'm going to do the same thing with the acceleration. So let me pick any number between 0 and 4.5. So let me pick 1. So check the acceleration. 12 minus 54, negative. So in this section here and in that section there, the acceleration is going to be negative. And now if I take something bigger, say I take t equals 5, 12 times 5 is 60. Excuse me, minus 54 is positive, so I know in this whole area, which means in both of these sections, the acceleration is going to be positive. So now it's very easy because everything is lined up. Okay, so where is it going to be speeding up? Well, anywhere where both of them are positive. Okay, so we've got here, where they have the same sign. So they have the same sign in this interval here. So between 3 and 4.5. So 3 less than t less than 4.5. Okay, but it's also speeding up in this interval where they're both positive. Okay, so here, or t greater than 6. Okay, now let's look for slowing down. We've got slowing down where the signs are opposite. Okay, so here they're opposite signs between 0 and 3. So 0. Now here, because the velocity is not changing sign here, I'm actually going to include 0. Okay, less than 3. But it's also slowing down where there's opposite signs in this interval, which is between 4.5 and 6. Okay, so there we have it. Set up, so find your derivatives for your velocity and acceleration. Set up a number line, which includes the zeros of the function, and then test the signs in all the possible intervals created by the zeros, wherever the signs are the same, speeding up, wherever they're different, slowing down. Okay, that's it for this one.